Pluto, officially designated as 1134342, Pluto stands as one of the most fascinating dwarf planets in our solar system, having undergone a significant reclassification in 2006 that forever changed its status in astronomical taxonomy. Originally considered the ninth planet following its discovery in 1930 by Clyde W. Tombaugh at the Lowell Observatory, Pluto was reclassified as a dwarf planet by the International Astronomical Union, IAU, when a formal definition of planet was adopted that Pluto could not satisfy. According to the IAU's definition, a planet must orbit the Sun, have sufficient mass to assume a nearly round shape under its own gravity, and have cleared the neighborhood around its orbit. This final criterion being the one that Pluto fails to meet as it orbits within the Kuiper Belt, a distant region populated with frozen bodies left over from the solar system's formation. The world was introduced to dwarf planets in 2006 when Petite Pluto was stripped of its planet status, with the IAU currently recognizing other dwarf planets including Eris and Ceres. Despite this reclassification, many planetary astronomers continue to consider Pluto and other dwarf planets as legitimate planets, highlighting ongoing scientific discourse about celestial categorization. Physically, Pluto is a diminutive world compared to the 8 official planets, with a diameter of approximately 2,276.6 plus 1.6 kilometers, making it smaller than Earth's moon. The dwarf planet has only about 1/6 the mass of our moon and approximately 0.0218 or 1 to 459 that of Earth. This relatively small mass had been subject to numerous revisions throughout the 20th century, with initial estimates in 1931 suggesting it was roughly the mass of Earth, later reduced to approximately that of Mars in 1948, then further decreased to about 1/100 of Earth's mass in 1976, until more precise measurements became possible with the discovery of its moon Charon in 1978. Composed primarily of ice and rock like other Kuiper Belt objects, Pluto's surface consists of a mixture of frozen nitrogen, methane, and carbon monoxide ices, with distinctive polar caps and various regions of frozen methane and nitrogen, creating a diverse landscape. The dwarf planet's mean density of approximately 1.853 plus 004 g/cm3 suggests a composition of roughly 70% rock and 30% ice, though the exact proportions remain a subject of ongoing research. Located at an average distance of 39.5 astronomical units, approximately 5.91 billion kilometers or 3.67 billion miles, from the Sun, Pluto experiences extreme cold, with average temperatures hovering around a frigid 356 degrees Fahrenheit, 215 degrees Celsius, contributing to its icy composition and unique surface characteristics. Light from the Sun takes approximately 5.5 hours to reach Pluto at its average orbital distance, emphasizing its remote location in the outer solar system. Pluto is considered a dwarf planet precisely because it has not cleared the neighborhood around its orbit. It orbits in a disk-like zone beyond Neptune called the Kuiper Belt, sharing its orbital space with numerous other objects of comparable size. Pluto's orbit is notably eccentric and inclined compared to the planets, ranging from 30 to 49 astronomical units from the Sun and completing one full orbit, a Plutonian year, in approximately 247.94 Earth years, meaning that in 2178, Pluto will complete its first full orbit since its discovery in 1930. This highly eccentric orbit periodically brings Pluto closer to the Sun than Neptune, though a stable orbital resonance prevents the two bodies from colliding. Pluto's orbit is also highly inclined at about 17 degrees to the ecliptic plane, further distinguishing it from the relatively flat orbital plane shared by most planets in the solar system. One of Pluto's most remarkable features is its complex system of moons, with 5 known natural satellites. Charon, the largest, along with the smaller Styx, Nix, Kerberos, and Hydra. Charon is particularly notable for its size relative to Pluto, with a diameter just over half that of the dwarf planet itself, approximately 1,212 kilometers, leading some astronomers to classify the Pluto-Charon system as a binary dwarf planet rather than a primary body and satellite. With a diameter of about 737 miles, 186 kilometers, Charon is the largest of Pluto's moons. This classification stems from the fact that the barycenter, the common center of mass, of the Pluto-Charon system lies outside Pluto itself. meaning the two bodies orbit around a point in space between them, rather than Charon simply orbiting around Pluto, as most moons orbit their parent planets. Additionally, Pluto and Charon are tidally locked to each other, meaning they always present the same face to one another as they orbit, a characteristic that has profound implications for the evolutionary history and dynamics of the system. The discovery of Pluto itself has a fascinating history tied to the search for a hypothetical planet X that was believed to be influencing the orbits of Uranus and Neptune. Percival Lowell, a wealthy Bostonian who founded the Lowell Observatory in Flagstaff, Arizona, initiated an extensive project to search for this ninth planet in 1906, though he died in 1916 without success in his quest. Following a 10-year legal battle between Lowell's widow and the observatory, the search resumed in 1929 when observatory director Vesto Melvin Slipher assigned the task to the 23-year-old Clyde Tombaugh, who had impressed Slipher with his astronomical drawings. On February 18, 1930, after nearly a year of searching, Tombaugh discovered a moving object on photographic plates taken on January 23 and 29, with a lesser quality photograph from January 24's helping to confirm the movement. After obtaining further confirmatory photographs, the observatory announced the discovery to the world, telegraphing the news to the Harvard College Observatory on March 13, 1930. The naming of this newly discovered world followed an interesting process, with the Lowell Observatory receiving over 1,000 suggestions. The name Pluto, after the Roman god of the underworld, was suggested by Venetia Burney, an 11-year-old schoolgirl in Oxford, England, who was interested in classical mythology. She proposed the name to her grandfather Falconer Madan when he read the news of the discovery to his family over breakfast. Madan passed the suggestion to astronomy professor Herbert Hall Turner, who cabled it to colleagues at Lowell on March 16th, just 3 days after the announcement. The name was considered particularly apt for multiple reasons. Both the mythological Pluto and the distant planet inhabited gloomy regions, and the god Pluto could make himself invisible, just as the planet had remained hidden for so long. Additionally, the first two letters of Pluto matched the initials of Percival Lowell, providing a fitting tribute to the man whose search had initiated the discovery process. The name was officially published on May 1, 1930, after unanimous approval by both the American Astronomical Society and the Royal Astronomical Society. Our understanding of Pluto was revolutionized by NASA's New Horizons mission, which launched on January 19, 2006. Ironically, the same year that Pluto would be reclassified as a dwarf planet. The spacecraft swung past Jupiter for a gravity boost in scientific studies in February 2007 before conducting a 6-month-long reconnaissance flyby study of Pluto and its moons, culminating with Pluto's closest approach on July 14, 2015. This mission represented the first and to date only direct exploration of Pluto, transforming it from a distant, pixelated blob in even the best telescope images into a complex, geologically active world with unexpected features and diversity. The New Horizons flyby revealed Pluto to be far more dynamic and diverse than previously imagined, with a surprisingly young surface showing evidence of recent geological activity, despite the dwarf planet's small size and distance from the Sun. Pluto's status as a dwarf planet, while controversial among some scientists and the public, has actually enhanced our understanding of the diversity of objects in our solar system. Its reclassification has positioned it as the archetype of an important class of solar system objects that appear to be far more numerous than the planets themselves. Whether considered a planet, dwarf planet, or by some other classification, Pluto remains a fascinating world of ice and rock, orbiting at the edge of our planetary system, constantly challenging our assumptions and expanding our understanding of the diverse bodies that populate our cosmic neighborhood. Through continued observation, exploration, and study, Pluto will undoubtedly continue to reveal its secrets and contribute to our understanding of planetary formation, evolution, and the complex processes that shape these distant worlds in the cold outer reaches of our solar system.